When we're looking at algebraic terms, we need to know what these terms mean and what they represent. In an algebraic expression, we have a coefficient, which is the number part of that, and that tells us how many. And we have the variable term, which tells us the unknown part, or variable or unknown term. And this coefficient counts the number of these unknown or variable parts there are. So an example here would be we have 4 cases of Coke and 7 cases of apple juice. So the 4 and the 7 represent the quantities or the counters, and those represent our coefficients. The cases would be, in this case, cases of Coke. So C would represent the cases of Coke, or the number of whatever the case of Coke represent, for example, the number of bottles of Coke in there. And the A would represent the cases of apple juice, and the A could represent the number of, juice boxes there are in there. So the coefficient is the counter or the groups or the multiplying factor, which counts the number of groups. The variable is the unknown term, and it could be the unknown or it could be the variable quantity, and this tells you the amount of Coke or the number of cans of Coke or some numerical quantity that it does represent. And we can combine coefficients of the same unknowns because they are like terms, and essentially they're like terms because they're counting the same thing. And if we can count the same thing, we can count them together. So example here would be we have 4 cases of Coke here, and we have 7 cases of Coke over here. We have 3 cases of apple juice here, and 2 cases of apple juice here. Okay. It's hard to see, so I'm just going to circle that. And we can express these as 4 cases of Coke and 3 cases of apple juice as 4C plus 3A, 7 cases of Coke and 2 cases of apple juice as 7C plus 2A. And we can combine these together because we can count all the Cokes together. So 4 cases of Coke and 7 cases of Coke add up to 11 cases of Coke. And since the apple juice are different, we can't count them with the Cokes, so we have to count them separately. So we have 3 cases of apple juice and 2 cases of apple juice, and that gives us a total of 5 cases of apple juice. And so the 11 is our multiplier, or it counts our groups of Cokes, and that counts the number of Coke, the cases we have. Here 5 is our multiplier, 5 is our groups, so 5 counts the number of cases of apple juice. And so these are like terms. Like terms can be grouped together or counted together or added together. So for the first example here, I've shown the like terms in the same color. So we have x's here, we have x's here, we have y's in purple here, y's in purple here. So here I have 3 x's, and it's important to make sure that you recognize the operation that goes with the x's and y's. Here we have positive 3 x's, that's implied, and we're going to add 2 x's. So it's very important to keep track of the sign here. So we end up with 5 x terms. Where it's really important is this next example where we need to keep track of this negative in particular. We cannot say 4 plus 7y because we have to keep track of the signs here. The plus minus signs indicate what we're starting with. We're starting with a minus 4y, and then we're going to add 7y's. Well, that means they're going to count against each other, and we're going to end up with positive 3y's. So it's very important we keep track of the plus minus. Okay, and the way we do that is we really need to look at the operation or the operator in front of the coefficient. That is very important that we keep track of that operator in front of the coefficient. So looking at this next one, we need to figure out which terms are like. So I'm just going to circle the 7 here. That 7 represents 7 1s. So I'm just going to see if there's any other ones and here. And there's 5 ones here. But it's important not just to see that there's 5 ones. We need to know what we're doing with those 5 ones. We're going to add 5 ones. So keeping track of that plus minus is very important. So here I'm just going to say I have 12 ones. I can look at the A's, and instead of keeping track of the A's, I need to not just keep track of the A's, but the sign in front. So keep track of what we're doing with those A's. So I have minus 3 minus 1, that's minus 4, plus 2 is going to give me minus 2 A's. Then I do the same for the B's. I need to keep track of not just the B's, how many B's I have, but what I'm doing with them, the sign that goes with them. So I have a minus B here, I have plus B here. So minus 2B plus 3B is plus 1B. And lastly, I have minus 7C plus 5C. I end up with a total of minus 2C. Now some people like to put these in alphabetical order, but it doesn't really matter. It is nice to keep it organized that way, but it's not necessary to do that. For this one here, we want to know how many A's and B's there are first. This 2 represent groups of all of this. So if there's 2 groups of A plus B, that means I have 2 groups of A and 2 groups of B. So I really should make sure that I account for that. And notice I'm doing my math vertically again, and I'm keeping track of all the terms in the next line. I just don't do the calculation part. I have to make sure I keep track of everything in that line. Once I've done that, I'm going to then combine my like terms. I have A's, a plus A here. That means I have positive 3 A's. And then I have my B's. I have a plus 2 and a plus 4. That gives me a net of plus 6 B's.